I'd like to welcome you all to CENG 490, CENG Project 1, our first presentation. I'll start first by introducing ourselves as group members. I'm Mohammed Mustafa Ashnawi, I'm the Chief of CENG and Public. Our topic that we'll be discussing throughout this presentation we're working on as our project is design of water, sewage, and irrigation systems for Royal City residential complex. This is a general outline of the presentation. We'll start first with a brief introduction about the Royal City residential complex. Then we'll have a comparison between the actual design and the proposed design, scope of work, design criteria, methodology that will be used, and the expected challenges that will be facing throughout the semester, and our time plan and references. First, Royal City is located in Sheikh Zayed City. I think this general layout shows where it's located. Here's Royal City. This is Lebanon Square. And this Hyper One. It's almost 20 kilometers away from Lebanon Square. Its total area is almost 1,580,000 meters square, and the construction of the infrastructure is still under progress because some minor parts of it have not been finished yet. The cost of the infrastructure is estimated to be 25 million Egyptian pounds. This is the plan for the residential complex. This is the plans for the 4-story building apartments, and these are the plans for the villas. This is a social area including soccer field and transports, and this should be taken into consideration when calculating the irrigation plan. We've been able to reach the contour map of the site. This is the highest or the most critical part, or 95 meters elevation above the sea level, and the slope starts decreasing till it reaches 73 meters above the sea level. This is the actual design concept. The intake is from there as shown by the arrow, and decided the area to deliver the sewage to Sheikh Zayed sewerage network. So the water, it seems that the pressure has been enough, the pressurized water coming from the government has been enough to deliver the water to all the residents without needing a pumping station in that place. As for the sewage, it has been collected by gravity till it reached the lowest point as was indicated in the Google Maps, and through a pumping station, it's pumped using force main till it reaches back again the area to deliver the sewage. Hassan will continue with the proposed design.
Okay, as Mohammed Ashnawi said, the original design creates a water cycle in which irrigation demands and residential demands of fresh water are met by the main source of fresh water. Sewage produced by the residential buildings and villas are then pumped through a force main outside the perimeter of the city. Our proposed design would ease the burden on fresh water demand and would emphasize on the concept of water usage rather than water consumption. Irrigation water needed for irrigation demand is certainly not at the same quality as the water needed for residential use. Therefore, if the sewage produced by discharged by the villas and buildings can be treated to a certain degree that would deem the water satisfactory for irrigation use, then we would greatly reduce the demand on fresh water, because the water for irrigation wouldn't be supplied by fresh water, but would be supplied essentially by the sewage itself after it is treated. In order to practically apply this concept, we have to design 3 main systems: the water supply network, the sewerage system, and the irrigation system. For the water supply network, it mainly would consist of a pumping station, storage tank, whether elevated or ground-based, depending on pressure availability and design needs, and the pipe network. Favorably for our site, the main source of water is at the highest elevation of about 95 meters compared to most of the area. So this might negate the need for a pumping station. The pressure head and the elevation head of the main source of water can be enough to distribute the water to all areas in the complex. However, the elevated tank or the ground tank, based on the pressure needs, as I said before, would have to be designed hydraulically and structurally. Also, the pipe network would have to be designed in terms of pipe material, pipe diameter, and depending upon the flow in each pipe and the design velocity for each pipe. Moving on to the sewerage system, it would have to be designed in terms of locating the manholes at strategic positions to collect sewage produced. We'd also have to design the sewerage pipes in terms of pipe diameter, pipe slope, and pipe materials, depending upon flow. And the force main, this is optional because we did not decide yet whether the sewage produced would be more than what is needed to be treated for the irrigation system. Maybe it could be more, so we need a force main to discharge some of the sewage outside the perimeter. Moving on to the irrigation system. The sewer system also would consist of a wastewater treatment plant. Our design for the wastewater treatment plant would only be limited to calculating the total sewage produced and then recommending the suitable compact model of wastewater treatment plant for the calculated total amount of sewerage discharge. Moving on to the irrigation system, as said before, the source for irrigation would be the wastewater, the treated water from the wastewater treatment plant. The wastewater treatment plant will have to be located at a really low elevation in order to collect all the sewage by gravity, which is why we need a pumping station next to the wastewater treatment plant to pump the treated water to all the areas needed to be irrigated at a relatively higher elevation. So the pumping station would have to be designed in terms of number of pumps and the capacity of each pump. Also, of course, the pipe network for the irrigation system would have to be designed in terms of pipe diameter and pipe material, depending on using the same criteria for the design of the freshwater pipes. If you would continue with the
Okay. For the design criteria, there are many conditions and givens that should be considered while designing the infrastructure for this project. First, we have the population demand, in which we estimate the total population that the compound can host, and the daily use of one person, the liters per capita per day, to be able to get the daily demand of water supply for the whole compound in cubic meters per day. Then we need to estimate the expected sewage discharges, which will be, according to the Egyptian code, around 80 to 90% of the fresh water supply. Also, for the head at the source of water intake, the source of water intake with its pressure head and elevation head will determine if we need a pumping station and elevator tank at the source to be able to satisfy the pressure at all nodes and velocities in the pipes. For the topography and physical plans, they will be needed for making the layout of the three networks with the suitable slopes, elevations, and direction of flow according to the plans and the position of the mountains. Also, we need to consider the types of green landscapes and the areas to be irrigated to calculate the demand for the irrigation network and the design of the irrigation network. Also, we need to consider the soil report to know the type and characteristics of the soil, and accordingly design the pipe materials, the location of the groundwater tank if we have one, and if we consider the replacement of soil in case of we have swelling soil, and if we need to consider the infiltration process due to leakage if the sewer pipes are under the groundwater table. Okay. Also need to consider the expected level of service to determine if we need a backup system in terms of electricity and pumps for the compound and the tolerance to accept the cut in all the stuff. And finally, regarding the firefighting demand, the demand will be added to the freshwater network, not as a separate network. We add it to the freshwater. Then moving on to the expected challenges.
Throughout the semester, we are expecting to face challenges, especially at the design stage. The first one will be the structural design of uncracked sections for water storage tanks. The second one will be the optimizing the three networks design according to the topography. And the third one is dealing with new software such as SewerCAD. Now moving on to the methodology, there are several softwares that we're going to use. The first one will be AutoCAD, WaterCAD, SewerCAD, and SAP. WaterCAD and SewerCAD are going to be used for designing the water supply and sewerage networks, and the SAP for the design of the water storage tank. There are also several reference books that we're going to use. The first one is the Fundamentals of Hydraulic Engineering Systems. The second one is Water Supply and Water Removal. And finally, the Egyptian Code for Sanitary Works, Code 101/1 and Code 102/1. Now for the time plan, by presentation 2, we should be done with estimating the water demand, the design of the structure and hydraulic design of the water storage tank, and the design of water supply network. That leaves us with the design of the water supply network and sewerage network, the design of sewerage network and irrigation network, which is almost about 40% of our project. Now these are the references that we used all over the presentation. Thank you.